Today we're going to do our last lesson on triangles, and this is on triangle inequalities. So the first thing that you have to know is you can't make a triangle out of just any three side lengths you want. There are some restrictions on that. So for example, if we try to make a triangle out of something that's 3 inches, 5 inches, and 10 inches, it's never going to work. If you put the 10 inches down here at the bottom, the 3 on one side and the 5 on the other, no matter how you position those, if they're attached at these ends, they're never going to reach one another. Thank you. Okay, the 3 and the 5 are too short. They're never going to span this whole distance. So, this leads us to the triangle inequality that says the sum of the two short sides of a triangle have to be longer than the longest side. That is always true. The two short sides have to be more than the third side. Now, the reason for that is, let's think about it this way. If you're going from point A to point B, the shortest way to get there is to go directly from A to B, right? Yes? If you go up here to point C, which may be more interesting to you for some reason, and then go from C to B, is that going to be longer or shorter than the distance straight from A to B? It's longer. You've gone out of your way. Okay? This is a pretty easy idea to understand. So here it'll say there are two different kinds of problems we're going to do with this particular theorem. One is determine whether a triangle can be formed from the given side lengths. And it's a simple idea. Take the two short sides and add them together. For number 1, that's 3 and 7. Is that bigger than 9? That's the question.
Yes.
Yeah, that's 10. So the answer to this is yes. You can make a triangle out of those side lengths. All right, let's look at the next one. Again, you've got to pick out the two short ones. So 8 and 5 are the two short ones. If we add that together, is that greater than 16?
No.
No, 8 plus 5 is only 13. So you can't make a triangle with those three side lengths. Look at this one where it's 6, 6, and 10. The two short sides are 6 and 6. Is that greater than 10?
Yes.
Yeah, so this is yes. And then this last one, the two short sides are 5 and 7. Is that greater than 12? No, it's equal to. If you were trying to make a triangle out of this, what would happen would be this, is you would have this side would be 12. And the only way to make them touch each other would be put them flat like this, where this is 7 and this is 5. Doesn't make a triangle, does it? Because there's no space in between those. All right, here's the second kind of question you'll be asked about these. It says, given the length of two sides of a triangle, find the range of possible lengths of the third side. In other words, what's the smallest the third side could be, and what's the biggest the third side could be? Now, there are two possibilities. The first possibility is that the third side is one of the two short sides. So one possibility is that the third side, I'll call it T, for the third side, is one of the two short sides. What's the other short side if T is one of the two short sides? 5. So T plus 5 has got to be greater than 7. And we're going to solve this. T is greater than 2. Stetson, you okay? So T's got to be bigger than 2. It can't be equal to 2. It's got to be bigger than 2. The other possibility is that the third side is the biggest side. So your two short sides would be 7 and 5. 7 plus 5 has to be greater than T. So 12 has to be greater than T. And it may be easier for you if you think about it as T has to be less than 12. So you have two choices when you write out your answer. I'm happy with either one of them. If you want to write it out in words, you could say it is between 2 and 12. You can also write it as a compound inequality, which sounds horrible, but it's pretty easy. 2 and 12 are the ends, right? I'm going to just say T has to be in between those two. 2 is less than T, which in turn is less than 12.
Can I put like 3 through 11?
No. Can it not be 2.5? Yeah, it doesn't have to be all integers. If they had to be integers, then yes, it would be 3 through 11. But they didn't say that. It's a good question. All right, so let's look at this one. If T is one of the short sides, what's the other short side? 11. T plus 11 has got to be more than 15. Subtract 11 from both sides, we know that T has to be bigger than 4. And then if T is the big side, the two short sides are 11 and 15. Those two added together have to be bigger than T. So 26 has to be greater than T, which means that T is less than 26. So T is between 4 and 26. I usually just write it out as a compound inequality because I don't like writing the words. It can't be 4 and it can't be 26, but it can be really close to either one of them. Like it could be 25.89 or 4.01, and those still work. All right, this last one is a little bit different. So again, I'm going to start the same way. Let's say that we think T is one of the short sides. This is going to feel a little bit weird because you're like, well, these two are the same. All right, well, I'm going to pretend that one of them is bigger than the other for just a second. Subtract and we get T's got to be greater than 0. Which makes sense. A side can't be negative, and it can't be 0. If T is the big side, the two short sides are both 12. So we get that 24 is greater than T, or if you prefer, T is less than 24. So that means that T is in between, not including, 0 and 24. Before we go on to the next page, let me just talk to you about what that would look like. If these two sides are both 12 and this one is really small, it might look something like this. Where both of these are 12 and this is something really, really small, right? Andrew, you okay? Looked like your attention wavered for a minute there. It's okay. But you can see how I could close the gap between those up to where it was almost nothing, right? On the other hand, I could spread those way, way out to where it looks something like this, where this is 12 and this is 12. And this isn't going to be equal to 24 ever, but we could make it pretty close, right? The closer these two were to being collinear, the closer this would be to 24. All right. Now for the other part of triangle inequalities. That's the first part. The second part is this. Everybody look at the diagram. Which side appears to be the longest side here? QR. Yeah, this is not a trick question. Which angle appears to be the biggest angle out of those three? Angle S. Angle S is very much obtuse looking, and the other two certainly look acute. Where are these in relation to each other? Well, they're across the triangle from each other. The math word for that is they're opposite each other. And that term has been used for things way, I don't know if it was before the math, but for example, if you are at a table, say in the cafeteria, the person who's sitting directly across from you is your opposite, okay? As opposed to the people sitting next to you who are adjacent to you. This also goes for formal dances. The person that's directly across from you, like in a square dance or, I mean, any kind of a thing like that, the person who's directly across from you is your opposite. I'm sorry? Yes. All right, so that's the biggest side and the biggest angle. Which side is the shortest side? RS is the shortest. And then angle Q is the smallest. Are those opposite each other also? Yeah, they're across the triangle from each other. So they are opposite each other also. So the theorem says this: in a triangle, this only works in a triangle, doesn't work in any other shape. The longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. So once you know either the lengths of the sides, you can find which angle is biggest and which angle is smallest. Or if you know the angles, you can figure out which side is the biggest and which side is the smallest. Frequently, these are drawn like this. Put the letters in order from least to greatest. So, for this first one, the smallest side is 11. The longest side is 19. So across from the smallest side is the smallest angle. B is going to be the least. Across from the longest side is going to be the biggest angle. A is going to be the biggest one, which means that C must have been in between the two. It's a horrible looking A. Okay, not a lot to do on that. You just pick out the biggest and the smallest, put them in order. For this problem, we don't know which angle is the biggest angle yet because we don't know how big this last angle is. But we can find it out. These two angles added together, 50 plus 70, is 120. Taken from 180 leaves that this angle is 60. So the smallest angle is 50. Opposite that is B. The biggest angle is 70. And opposite that is C. So A must have been in the middle. Okay, any questions about that? All right, your assignment on this, I believe, is in the book. Let me double check. Yes. Please be reminded that tomorrow we'll be taking the quiz on angles of triangles. It won't include isosceles triangles. It won't include what we learned today, but it will be about angles of the triangles. You have a worksheet called Angles of Triangles. That might be a good thing to study. Yes, sir.
For test of the day.
Test is on Thursday, yep.